And the final speaker between you and dessert is Frans, who worked hard with me to organize this event, though I should say that almost all the work was done by Sheila Marion. Sheila. So thank you, Sheila. Frans?
Good evening, all. I hope you're having a good time, because it's going to end soon. John told me, why don't you take the boring technical part, and in fact, you can have 7 minutes as opposed to all the others. And so I thought a little bit about this, and it will be a little bit boring and a little bit technical, but I mostly will talk about 6 thank yous for what all the work that Barbara has done. And I hope in those 6 thank yous I will echo a lot of what probably people are thinking here in the audience. So the first one, I have to say, because I'm a programmer, I love programming, and I got to thank Barbara for abstract data types. As a programmer, you use it every day. It helped you structure your code. It's more robust, it's more maintainable, it's more readable, so everything's good about it. But I don't want to stop there because Barbara made many, many other contributions. And so I want to talk a little bit about some of the other contributions, and particularly in the area of distributed systems. So I put this timeline up, and you can see that in every decade there are major contributions. And in fact, I just picked the project with the shortest names because I couldn't fit them on the slides. And so I apologize to all the students and postdocs that have worked with Barbara and whose project is not on this list. I feel very embarrassed about this, but PowerPoint just doesn't have longer timelines. I can't do anything do about it. And Andrew talked sort of eloquently about the programming languages side, but I want to talk a little bit of a completely different side of Barbara's research, which is distributed systems. And I'll pick 2 particular topics for no other reason that they're easy to explain. And so, again, I apologize for the people that I'm not explaining their research. So the first one, I guess, is view-stemmed replication. So if you use any cloud service, and when you work at Google or you use any of the Google services, one of the major goals is to make the systems highly available. You're running lots and lots of computers, so it's very likely that one computer will fail, but you want to make sure that every customer can get to the data quickly. So the obvious approach to that is, of course, replicate the data on multiple computers. And you might think, well, that sounds straightforward. I can design a system like that. And so, for example, let's say you have 3 computers, we have some bank account on it, each containing $100. And somebody, some client, say, Barbara, deducts $20. Now, that's straightforward to do. You just send messages to every computer, correct? And you deduct the $20 and you're done. So how hard is this problem? Well, it turns out, if you start thinking about the corner case, it turns out to be pretty hard. And I see Brian shaking his head here. Because, what's an example happens if you have a network partition? Well, you send it to 2 computers. And those 2 computers deducted $200, but the computer that's in the other network partition, of course, doesn't get the message. So it will stay at $100. You say, what is that a big deal? That's not a big deal. Well, let's say there's another client, say Nate, who's sitting in the other network partition, can talk to the 2 computers that have the $80, but can talk to the computer that has $100. So he looks at the account and says it's $100. Now, clearly this is not the right outcome. This might lead to some discussion between Barbara and Nate about where did the $20 go. But there's a larger issue here. Clearly, the desired property that you would like to have is that, despite any sort of scenario of failures, you would like to stay the data consistent, that at any computer the same data is present. And so Barbara and students and postdoc working hard at this problem, and one of the early ones to actually propose an protocol that solves this problem. And that particular protocol is view-stemmed replication. And any user of sort of a cloud server today, whether it's Google or Amazon, inside of it, you will see a protocol that either is view-stemmed replication or a protocol that it looks actually very similar to view-stemmed replication. And so I would like to thank Barbara I use Google for email. Sorry to say that, but, and not Microsoft. So anybody who's working for Microsoft, sorry about it. I think most students actually in Barbara's group actually work for Google. How many of Barbara's PhD students work for Google? Well, I should accept. So I will keep using Google as an example. And anybody can thank Barbara basically for the fact that we have reliable, distributed, fault-tolerant computer systems. Now, This problem is in principle hard, but in this particular scenario, we're taking the assumption, or Barbara took the assumption, that all the computers are actually honest. You know, they actually follow the protocol, they do what the protocol says. And of course, it's interesting to think about, like, let's make the problem harder. So one way to make the problem harder is to say, like, well, some of these computers might actually be compromised, right? They might be, an attacker might control them, and the tracker might actually want to, trick, the clients or the other servers in actually doing the wrong thing. And so that problem actually was an open problem, has been an open problem for a long, long period of time. And Miguel and Barbara were actually sort of first that came up with actually a practical solution to this. And in fact, this turned into a whole research cottage industry where every year, for the last 2 decades, there are a couple papers in every conference that actually talk about yet another version of BFT. So I want to thank Barbara for keeping the computer science literature rich, with protocols based on BFT, and forcing me to read more and more papers on BFT. But, sort of joking aside a little bit, I also want to say something about the students. We have a lot of students in the talk tonight, and many more will actually talk later. And they can't sing their own praise. I mean, they're trained well by Barbara to be modest, to talk about their technical work, about the contribution. But clearly, if you look at the students and the way you speak even tonight, you realize that these are very, very special people. And there's a poster outside with Barbara's academic tree. There might be bugs in the tree, so I haven't been able to track everybody down. But if anybody has actually is missing, please let me know. The poster was actually put together by James. I mostly functioned as the remote printer. And James Coling, who couldn't make it tonight, but sends his regrets. Here's a small fragment of the poster. If you actually go down, you will see that the poster is much, much, much larger. I think I counted 127 descendants, or academic descendants of Barbara in total, or actually I had Justin count them. I didn't want to count them. And one of the things you will notice if you look at the names of the poster, and in fact if you look at the names around in this room, that many of the people are extremely famous in their own right, whether it's in academia or in industry or any other setting. So I would like to thank Barbara for basically training and multiple of really, really talented students, and thanking for coming tonight. Now Barbara's not just about keeping her students on track. Barbara is a leader in the systems group, basically either on the 5th floor or on the 9th floor. For all the people that lived on the 5th floor, I brought the original 5th floor design plan. So if you want to come back later and find out where your office was, you can look at this. Unfortunately, yellow is not a really great way on PowerPoint. It was not my decision to paint this thing yellow. Long gone before my time. But I would like to point out that Barbara, often in conspiracy here with John, were the leaders of the systems group and were very strong advocates for junior faculty, guiding junior faculty, hiring new faculty, advocating in general in the department or even in MIT that systems was an important research area. And as a result, I think for the writers and many systems faculty here in the room have benefited from John's and particularly Barbara's advice. As was pointed out, Barbara is a very clear thinker. You just go to her office, you tell her a problem, you get the solution, right? And it's always very simple and straightforward, and you're always like, why didn't I think about this? It seems like absolutely the right thing to do. But I think the larger point here is that under Barbara's and John's guidance, it's probably fair to say that the current systems, faculty, and I'm counting 7, 8, and 9, is probably one of the strongest systems research groups in the world. And I think we owe Barbara and John a big, big thanks for being able to select and support, new incoming people. Now, Barbara's not just all about work. You probably have noticed this coming up a couple times. And in fact, Barbara has many, many interests outside of work. In fact, Barbara is extremely impressive. She always doesn't seem to work very hard, but she has to seem to have time for all kinds of other things. Gardening, book reading, and things like that. And in addition, hosting parties. And you probably recognize these 2 pictures. How many people of you have been at a party at Barbara's house? Close to the whole room. That's pretty impressive. And I think this has created a very collegial atmosphere at MIT. And in general, it actually also brought a lot of people to come. A lot of them, these parties are recruiting parties. They seem to work reasonably well. So I want to thank Barbara and Nate, particularly for all their hospitality. More on a personal level, this is a picture of, I guess, a Thanksgiving dinner. If you look at Thanksgiving on the internet, this is a picture you get. They're not as cool as the Liskov substitution principles. They seem to be much more cooler pictures. But, Mathilde and I are from Europe, the Netherlands. We had no idea what Thanksgiving was. It seems like a pretty boring, party, eating turkey. How can that be cool? But Barbara and Nate invited us, and we actually had many Thanksgiving dinners with the extended family at their place. And started to realize, how good a tradition it actually is. And in fact, this is a tradition that we adopted, and we yearly now hold, Thanksgiving dinners, and appreciate it. So I want to thank Barbara and Nate for their friendship and for their many decades of support. So as you well know, behind every strong woman, man, is a strong. So in this case, I guess behind every strong woman, there's a strong man. So I want to thank Nate. A little bit because Nate actually got me back into squash. And as you well know, Nate doesn't like losing. And in fact, because of Nate, I have become a much better squash player. So Nate, thank you very much for all the squash games. And so to conclude, I just want to thank both Barbara and Nate, and thank you very much.